Excuse me. Okay, g'day, Chris, Brook,
How you doing?
Brook, Chris, Vee Two Australia, Project 860. Now this is episode 10, and we're still on the engine. So what we're going to do today is put the crank together. You saw in episode 8 where we pressed the crank apart, and Brook talked about all the issues that you can have and whatnot. So this crank we're going to do is not the crank out of Project 860, it's a customer's crank, but the process is exactly the same. And we're going to do a lightened and balanced crank for Project 860, and this is a lightened and balanced crank. And we'll show you the difference at the end between that and a standard crank. So there's only the two of us, so Brook's going to be the face, I'm going to be the back of the camera, so take it away, Brook.
Thanks, Chris.
No dramas.
Okay, so firstly, this particular process of pressing and screwing the crankshaft is probably not something that you're going to do at home. I mean, there are guys that do it at home. They know they've got the gear to do it and the wherewithal. But look, it's good for you to understand what's involved in pressing and screwing a crank. People get confused with balancing and pressing and screwing. I mean, I've seen it written in restoration books that they don't know the difference between pressing and screwing a crank and balancing a crank, which I'll go into later. This crank's already been balanced. It's been lightened, then balanced, and now we're pressing and screwing it and assembling it so that it can go in the engine. So this jig here, there's two parts to it. You'll see the other bit in a minute, the top of it. This is actually the second one that I've made in my time working on these bevel drives. It's what they call a standard die set, and it's used in tool making, and you buy them blank, like you just look like it's a blank set, a top and a bottom. Doesn't have any holes in it, it's just blank, and you use to make press tools. You can use it for all sorts of things. They go in machines and they can chop stuff and bend stuff and whatever, but in this case you can get 2-pillar ones, short pillar ones, long ones. So this is actually a 4-pillar, which means that the top and the bottom will stay more in line. I mean, a 2-pillar one would as well, but this one won't flex, whereas a 2-pillar one could in this situation. And it has, what I did was I bored a hole in here in the bottom platen, and I bored a hole in the top platen, and I fitted 2 main bearings, the same size bearings as a main bearing in a Ducati bevel drive, and so that the 2 main bearings are dead in line. And so when this tool closes in the press, the top journal and the bottom journal on the main is lined up, and it puts them together. It also holds the wheels all square, so that which I'll show you. Often I pull cranks apart that guys have done in home workshops or whatever, and the crank pin goes in on an angle. These cranks are 5 to 6 thou interference press fit. Now that is huge, and they go in cold, and the pin is hardened like 62 Rockwell. The wheels normally are made of like 4140. Some are softer than others, but that's what they're supposed to be. And the holes that the pin goes into are all honed to a really good finish, and if you don't use the right lubricant when you put it together, the right anti-seize paste, you will wreck the crankshaft. It will gall the crankshaft, and that's it, it's finished. You throw it away and buy another one, or bore it and sleeve it, or whatever. But I do see a lot of that from people pressing cranks together. I mean, look, a lot of shops do crankshafts in a traditional way, not using this. I use this because that's pretty well the only crank I do. So I've built this jig just to do bevel drive crankshafts. And if I was a jobbing shop that was doing Yamaha, Kawasaki, all sorts of 2-stroke cranks and whatever, then I probably would the odd crank I wouldn't use this jig, although I do use it, but use a different bush in here. I also have done Leverter cranks with this because they're a 3-cylinder and they're quite complicated. But these platens stay dead square when they come together, so the pin doesn't go on an angle and it doesn't destroy the crankshaft. So I mean, it's just a safety thing, I guess. And of course, it speeds up the job. and it's a better job and it's safer and everything. So here we go. I'm going to put the bottom half of the crank in here. So that's the journal, that's the bearing in there. So we're going to locate that on there, and that will just go in and locate in the bearing. There you go, like that. And you can see that's gone down nice and flush on there, on the die face. This is going to go in here and hold it. Now that holds that just stops it and keeps it flat, I guess. So that pulls that side down, and then when it's pressing, obviously it's going to press on there. So now we've got a pin, which we have here. So this is the crank pin, and this is one of our pins. The thing about, one of the main things about this, and even the factory ones aren't, see the radius on here is, I actually, when you grind it with the cylindrical grinder, even if it's got a radius on it, when you grind it, you'll always still get a sharp edge, although there is a radius. Now, the radius will make it less, but you'll still get a sharp edge. So after they ground, they go in a polisher and we polish that edge, so it just breaks that corner, so that when this goes in and it's pressed in, it is not going to go in, because in actual fact, Chris, that's a 36mm hole, not a 38.
Oh.
So we'll have to use, well, you get a 38mm pin. We've got 38 here, which are here.
So do you want to explain just quickly?
Yeah,
that's an early
these
crankshafts
come in two sizes, 38 and 36, and the early cranks were 36 and the late cranks were 38. And I don't know, you may remember when we did the episode on the crankshafts, we had large rollers on the early cranks and small ones on the later cranks, and what they did was they put a step pin in the, so they had that's your small diameter, it's a 36, 38. So if it was a 38mm crank, it'd be 38, 38, 38, which is this one, the straight one. And this crank although that's right, that bike was quite an early Dharma. And the early ones had a 36, 38. They all had the late model rollers. All the Dharmas had the late model rollers, but some of them had early 36mm balls in the wheels. So this is one of them. So I'm just going to get a vernier, Chris, which I don't have. Do you want to?
I'll go and grab one.
Yeah. Okay. There's one. Actually, there's one on the lathe where what's name is working.
Okay.
Here. So that's the other thing about this. We run two different widths on here because we have the original thrust washers, and I think we went into this in the last episode. The standard thrust washer is like 1mm thick, and we machine the side of the wheel here. That's 1mm. It's a standard washer, 80,000. 1.6, and these are 1.62, which is your thick washer, and these are nitrided, and they're far stronger than your standard washer. You can see the difference. If these do thrust, they'll bend and they wear out quickly. These, because they're nitrided, they're just a tougher washer, and they won't distort if they get hot. So when we do one of these cranks that's got, and we machine this off on a lightened crank, we machine this face and we take 0.6 off, and then we have to make a longer pin. So that's 47.4, which is a long one. See what that one is. That's 45, and that's 47. So that's definitely a long pin. So the 47mm pin is for the thick washers, and the 45mm pin, I'm talking about that dimension over that step, because we've machined it off that, and the pin bottoms out on that step. So. If it's a standard engine and the guy's not going to be racing it or whatever, the standard thrust washers are okay. But if it's going to be a performance crank, it may as well have performance thrust washers in it. So I use this product, which is made by a company in England called Rocol. I don't even know whether you can still buy this. It's called anti-scuffing paste, and it's the most amazing lubricant for pressing that I've ever seen in 50 years of engineering. That was full when I had it, and I've had it for the best part of 40 years. And mate, what's on my fingers enough to paint your house. It's unbelievable. It spreads like it's incredible. So you just need a little bit of that in this hole here, and I put it at the top of the hole. So when the pin goes in, it'll push it down. If you put it on here, it'll just push it up. It won't stay on the front of the pin and lubricate it as it goes in. So you've got to make sure you get it on there, a little bit on that radius, like that. Okay, so this oil hole is, the oil comes up in here, comes up the crankshaft, up the end of the, which I'll show you when we get it out, comes up there, in through here. It's got a set of centrifugal sludge traps in here, which fill up from the outside. And the oil comes through, it comes up a drilling here, into there, into the pin, and then out these holes to lubricate the rollers. And it also comes out of this little hole here, which lubricates that thrust washer. And the factory don't put any lubrication on the other side, which is a bit strange, but it's just how it is. So, yeah, it's you'd think that they would, but they don't, and they never have. So this is another piece of the jig. So that is a good fit in there, like that. And we put that on here, and we line that little hole up, we line up with there. We line that up with there like that. And that, so this face here is dead square with this, and well, square with these pins, and flat the same as this face, because it's all machined. And when we drop the top on this, the top will come down and it'll press on there. And if this is a little bit like this way or this way, the top face of the tool will pull it around and line it up, and happy days. We just grind it. It'll line it up and make it nice and square. So this is the top half, and we've got to get that lined up. That goes on there, and I'll put that there. And drop that on there. Like those pins and bushes are like less than half a thou clearance, and you saw where that went on, so it's a pretty accurate jig. And if we look under here, that has pulled that down nice and flat. So that's all square, the pin's all square, and that's ready for us to press and close that up. And it'll probably take about roughly 20 odd tonne to push that together. Sometimes they're more, sometimes they're less, but that'll use about 20 tonne. And I've got I'll use this, which is the thing that we used when we did press them apart. And what that does is that spreads spreads the load that you're pressing from this little bit over this area, and puts the load all over the top of the press tool. We got that in there. That pushes on there. And a bit goes in here, like that. So that's going to press onto that. That'll just do the load through these big things, which are the bits that actually we use to press it apart, and then it presses onto this here and presses all over this platen. Whoosh, down it goes, and happy days. So it's a bit noisy. This motor's a bit noisy. You won't hear me, I don't think. But here we go. Righto, so that's the first stage of putting our crank together.
Now, the idea there, you don't want to be off and on as you press it in.
Oh, right, yes. Well, I didn't explain that very well, did I?
That's all right.
Not that I didn't mean to, Chris. I just thought you'd have worked it out.
Yeah, well, I've worked that out, but what about the people watching the video?
Yeah, all right. You keep your head on. Righto, so you're quite right. Everyone's press is going to be different. I built this press when I built this tool a long time ago, and it's electric, and it's got I have no idea what the ram's out of, but it's massively long, and I use it for all sorts of things. I mean, that ram will go right down to here. It's crazy. But it's really handy, and I mean, this press here, Chris, is something you buy in Auto Barn or whatever.
Oh yeah, yeah.
And man, I've done heaps of these cranks on that press.
Okay.
And you know, it's got a bottle jack in it, and it's only a matter of getting the right jack that does the job. It's a lot slower. It's a bit cumbersome. It's not. You see it bending and struggling a lot more than what this does. This is a lot faster because you're not pumping the thing up and down, and it's just not so awkward. I mean, but it's purpose built, really, for this job. I mean, it's pretty common garden press, really, but I built it to do this job. And you can do it as long as your press has got enough grunt. It'll do it. Which I don't know what that one. You have to look in the label. I don't know what the jack is, but it's I think it's maybe I don't know. I know, it must be on the side. I think is it 20 or 10 ton? I don't know. Might even be 5, I don't know. But it does, I have had cranks where it does struggle.
10 tons.
10. So I've had cranks that have locked that up and won't do it. And I've actually had to put, I had this closed, and I put a porta power, a 20 ton porta power in here.
Oh,
and
wow.
use the porta power ram to press the pin out. On one that's really tight.
Okay.
But I've never had one that wouldn't push together, but definitely had one that wouldn't push apart. And but anyway, that's how I did it.
I guess the question is, one smooth action compared
getting back to the smooth action thing, for sure, you won't get a smooth action with that because you're pumping and it'll build pressure up, and then it'll go bang, and then you go a bit more bang, and that's not as nice as this. And I can control this with this lever here, and that smooth action is it's nice too. It does. It definitely sounds better when it goes.
If you have to use one of those other ones, you can.
Look, I've known people who've used them for years and years, no problem, never an issue. So, right, so now I'm going to knock this top plate off this die set, and to do that, I've taken that out, and I'm going to...
Your hand or... You're right?
No. I've done it myself a few times.
Yeah, you're getting old.
Yeah, I know. That's only a rumour. So I'm going to push this apart with my hand here, and I'm going to belt it here, and it's going apart, see? It's sliding apart. And there we go. I hate to think how many times I've had to pull that apart, but there you go. So it does save a huge amount of time to when you're doing a crank like this. Righto, so now we're going to pull that off there, and we're going to load the big end itself, which is, we don't take that out because that's done. So that pins in and it's nice and square and it's all happy. So what we're going to do is
Excuse me.
we're going to put a washer on there, and we're going to put a couple of cages in here and load them up with oil.
I'm zooming in manually because I can't get the zoom to work.
Right, okay. And you'll see it's got a step on top of that pin there, and that is for the other washer, the other thick washer to go on. Whereas a normal step pin wouldn't be there. See, that's going to locate. That's your small diameter of the wheel, and that's your big diameter down there, and that's going to locate on there. So the rods are going to run in between there. Just
a question for our home viewers.
Lay it on me.
What is the size, if you're doing a standard crank?
Yep.
So the standard bush, or thrust washer, sorry, is a mil.
1 mil.
But the factory
and
states 0.9 or something, does it?
No, the 1 mil thrust washers they must be. I would say they'd be special from the factory that they had made. I've not found any like it as a regular supply. You can buy the thrust washers you buy as a regular supply off the bearing companies are 0.8 or 9 depending on where you get them from. Right. So I mean they're okay. I mean the to be honest, Chris, the clearance on the sides of the rods on a roller big end is not an act of parliament. It
okay.
Really isn't.
Now, the other question is, do you look for, this is for the viewers at home, mind you, do you look for an overall width of the crankshaft so that when you're putting the cases together, you know, you see people put two gaskets in there and stuff because it's not right?
Yes, that's, 100%. It's a very good question.
I thought so.
If you're doing, I mean, look, I've had people who have had cranks built and they ring me up and go...
wrong way.
They ring me up and go, I've had my crankshaft rebuilt and I go to put it in the crankcases and I've got to put 2 crankcase gaskets in it to get it to shim. Not uncommon, and you know, I mean, it's an easy thing to do because these things are shimmed quite delicately in the side thrust of the crank, and the width of the crank is more important than some other cranks. So in actual fact, as long as it's not oversized, that's no problem. Yeah. And the reason I was measuring that step there and the width of that step in the middle of the pin, on a step pin, it's easy because if the step in the middle is right, when the webs press onto the pin, they go up against the step, and that's it. It's set, and you know you can't get it wrong. On a straight pin, you certainly can get it wrong, and because what you're using as a stop is the width of the rods, which are supposed to be 22 mil. So you've got 22 and 22, so 44. And you'll see when I put the rollers in the stack on, I put a 20 thou, or 0.5 of a millimetre shim on top of the thrust washer, and when I close the tool, the crank will go down and touch on here, and that will give you the right width.
Okay.
If the con rods weren't 22 and they were worn or whatever, and you do see that, and you do that, like if you're putting a new big in, it ain't going to happen. But basically, if the rods are 22, which is 44, and you put 0.5 of a mil on the side, it will be the right width. And if the rods aren't, let's say the rods were 21 and you were missing a millimetre off the rod, so you'd lose 2 millimetres because you'd have both rods, you would have to allow for it in these shims. So you'd put thicker shims in to jack it up so that when it came together, it would be the right width. But I have got a measurement for the crank, and it's 101.4 or 101.4, I think. And you measure when it's finished, you can measure across it and go, oh, that's okay. And if I'm doing a crank where I'm sending it out, I will check it. Yep. But if I'm doing one here, it's not really. If I use my stops, it will be right. So these are the rollers we washed up. Yep. And we're going to put some oil in them as well. I'll put a bit one in. Okay. You know, there's whether you assemble them with grease or oil. I mean, I use oil, but you know, I've seen people use grease. I've used grease for one reason or another in the past. And as long as if you're using grease, you want to run it carefully when you start it up, because grease does have a lot less, more friction because of the thickness of it than oil does. But it certainly, if you're careful, it won't do any harm, that's for sure. And I've seen them come packed in grease and oil from the factory, but of course, normally you would take the thing apart and wash and clean it before you assembled it anyway. So this is I mean, basically as long as your hands are clean and don't have any grit and stuff on them. It's a bit messy, but it's fine. So that is the bottom one, and I check that I've got all the rollers in, and I have, so I'm going to get my rod, and I'm going to put a bit of oil on that as well, and run it round. And these rods are good rods. I'm going to put that on there, and that's it. Beautiful. The other thing that you can check, which is probably not a bad thing, but sometimes the rods are not, these two faces here are not in the middle, or the rod beam is not in the middle this way.
Okay.
So when you put the rod on, this one's all right, I can see by looking at it, but if you look at that, see the gap under there?
Yeah.
See the gap in here?
Yep.
So
like here.
yeah,
So
right there.
you don't want that to be touching.
you don't want
the
that to be
crank rod.
touching, and I think we did go into that in the other episode, and you can actually see on the rod where it's sitting. So I look at that gap now. I'm not measuring it, I'm just looking at it and seeing what it is, and then I'm going to turn the rod over, and I'm going to put it back on, and like that, and basically that little gap is the same both ways.
Yeah, cool.
So that's what it should be, but I check them just to make sure. So and you'd be surprised how good your eyes are. I mean, if that rod was 0.2 off centre, when you put that on there, it'd actually look like 0.4 when you turn that over. It is 0.4, but because it's 0.2 off centre, so it's 0.2 each side. So you can pick that up with your eye, and you push the rod down and move it and off here, and make as long as it's missing the wheel, this wheel, then it's missing. And if it's missing by 1 thou, it's missing by a miss. It's a miss. So like, don't get too stressed about it. But I always put it with the largest gap that I can, so that the rod will allow you to do. And in theory, they should be the same, but like I said, they're not always.
Just another thing for the viewers at home.
Yeah.
You'll notice, and we have seen cranks that are like this, but has a thrust washer on the outside of the rods, not on the inside, not in between the rods. So,
yes, we have seen people put thrust washers in the middle.
So just
and well, look, do you know what? I've done it on specials, but they're not standard thrust washers, and you've got to be careful what you're using and where they fit, and whether they fit on the pin, or you couldn't put it. It's got to locate on the pin between the washers, and then you've got to have room between the cages, because if the cages were to lock up on it, that would be a catastrophe to say the least. And man, I've seen that as well. I mean, I've seen people put the washers in between the rods, not on the outside, and
it's just people not knowing.
People, no, it's not a matter of them being incompetent or silly. They just don't understand. They've not done one. They've not, and it happens. It's the more you do, the more you understand it. And although having said that, I don't know I've ever seen an engine that runs the thrust washers in the middle of the rods. I guess there is.
We talked about that actually.
We will. I'll do the same on this, because this is going to have. I'm doing this now because I can. So this is going to go on here. That thrust was going to go on there, like that one is, and I'm going to put that on there and push it up against the thrust washer, and there you go. It's got clearance. You can actually see that one. See the clearance in there? See that little gap in there? And if I turn this rod over, the thrust washer's stuck to it, like it would. Turn that rod over and try that on there. And there you go, there's a closer case. That one is going to hit. So if you put that on there, put it under hold, and slide this back,
you can hear
look, you can hear it. See, so I'm holding that flat. I'm holding that flat as it would operate in the engine. Slide that round, man, that is missing by. Oh no, it's hitting. It is hitting, but I mean just hitting. You can just feel it. So it hasn't been hitting on before. So if you put it that way, it's got at least 0.5 or more clearance.
Okay.
But the other side is actually touching. So it must go that way. So this rod has to go on like that.
Yep.
So we just do a check on the rollers again. Make sure you counted them right, Chris, because
22 in each one.
what did you do once you got your
What?
hands and feet used up?
I don't know. I wasn't very good at maths at school.
Oh, you use your ears.
That's right.
I thought you were going to come up with something ridiculous.
No, well, I was going to say, luckily I was good at English. I can spell better than most people here. Poor bastards.
Yeah. Righto. So we've got that step sticking out here. See that step on the pin is sticking. You can just see that there, like that, and that's going to go down, and that's sitting on top of the step there, and no, it's not. It's sitting on top of the step there, like that, and I push it, down it goes. All right.
Yep.
So that's it.
On the
And
step, yep.
when I push this together, I will be putting that's the step on that. The step on that is just above that and probably not enough clearance. So we will give that, we will put the shims in there, but we'll make sure that they go there and not there. I'll just make sure that they, yep, that's all right. Yeah, so we'll put those in and we'll make sure that they don't, so this shim won't go over that step, like, see, that'll be too high.
Yep.
But it's just dropping down a little bit below it, and that'll be happy days. Righto, so we're going to put some more anti-scuffing paste from Rocol in England. Like I said, I don't think they make it anymore. I'll put that in there, like that. And put a bit on there. Just for the hell of it. Get that on that radius. And we're going to load this. You might have to come around here, Chris.
Okay.
We're going to load. So there's the top. There's the top of the jig ready to go on. So I'm going to load the crank into here, like so. That's in on its bearing, and then I'm going to put a clamp on this one to hold it. I'm actually going to turn that so that that is not lined up, and I'll show you why in a minute. Because when we go down, when we put it together, we don't want, when we put it together, we don't want the pin to line up with that hole to start with. We want it not to line up. And there's a reason for that, but I'll just snip that up with my Allen key. Snip that bolt up, and that'll stop that from turning. And then we've got that on there, we've got that there. So I'm just going to put a bit of oil on there every time, just to make it easier to get on and off. Get off. Any magnets. In there, and I'll put a bit on these pins as well. Die sets are pretty neat things, really. These die sets get used in the industry of tool making a lot. I guess not so much these days with CNC machines making, you name it. So we've got, but you can still buy new ones. Okay, so this has got 3 holes, 1, 2, 3, and so is this top one. And you've got to have the 3 holes on this one in the same position so it goes back on. I guess you could say it's sort of timed in a way. So, lucky I've eaten my porridge this morning. So that's going to go on there.
Yep.
I sit it like that.
And the 3 holes.
So those 3 holes line up with those 3, so it's not the wrong way round.
Okay.
And I'm going to slide this over until the pins line up. And that's it. And away you go. There you go.
Okay.
Down she goes. And what's happened is that, I don't know if you can see under here with the camera, but you can see that the pin and the hole in this are not lined up because I indexed it round so that it wouldn't line up.
So the webs you can see aren't lined up.
So when I dropped that down, the die set came down. This half the crank came down, and it's basically half a hole out. So it's hit on the crank, and it's ready for me to bring this round. It'll come round, and it'll line itself up in the hole. And as it does that, I'm going to tap it down with the copper rawhide hammer, and that makes it engage nicely in the hole. And if I put it so that it was sort of roughly in the right place, it could fall into the hole when you go down, and it doesn't, you just don't know whether it's exactly right, and you can't feel it and you can't hear it, and so that's why I do it. So I'm going to turn this around now, turn the crank around, and the hole will line up like that, and I'm going to belt this down, and there she goes. That's gone in. So that pin has now gone into the hole, and I'm just going to seat it in there and lock this up so that lock that up. So that's pulling the crankshaft web hard up against the inner face of the die set, and that's it. I'm going to put the shims in it. I'm going to put this on, and I'm going to close it up, and we've got a crank. Basically, I'll put a bit of oil on these to make them stick. You've got to be a little bit careful with these because you can't push them if you push them in too far, they'll hit that step on the pin, and that's not what we want, because you don't want to measure, we don't want to give it this measurement off the step of the pin. We want it to come off the thrust washer.
Yep.
So it may not even hit this. They don't always do it. It may bottom out. The pin may bottom out on the thickness of the crank before this touches, which doesn't matter. Some do, some don't. It's just the machining isn't brilliant, mega accurate on these things. So, well, on the thicknesses of the cranks anyway, which doesn't really matter. You just got to allow for it. All right. So that's our liner. We'll put this. This is a hardened and ground piece of plate. It's actually the backing plate of the cylindrical grinder. And I'm going to so the ram is here. So I'm going to basically line the ram up sort of with the pin. Well, it doesn't have to be exactly, but you know, roughly. And the same way there. And that's it. I'm going to close it up, and that's missing that. Righto, so I'm going to turn the press on, I'm going to close it up, and that's it. There you go. And yeah, that's nip those shims, but if I move these rods, I'll get them out like that.
Beautiful.
That's it. Happy days. So we're going to do the same process we did before to knock it apart. Pull what's off. How many times I've lifted that up and down? I don't know.
Well, I think I need to sort this camera out a bit.
You do?
Yep.